All right, we're gonna go to PyCharm, Pops Chapter 605. We import pandas as PD. We import OS. Let me see well, evidently I needed it for something because otherwise it would indicate. Oh yeah, yeah. Okay, I remember now. And then we also import something to read XML files. So here, what I did was experiment with the displaying functions of Python. If you run this options display.max rows and max columns, you get the current default. So in my setup, I have a maximum of, by default, maximum number of 60 rows and unlimited the number. I think it's unlimited numbers of columns. Then I changed that to 36 rows and no maximum of columns. So you get this. You get 36 for the rows and none. No max, I suppose, for columns. Yeah. Yeah. This is the setting. This is the printing that prints that. Example A. Print the contents of a folder. This does not use pandas. What I wanted to show you here is how to print the contents of a Windows folder. So you create a variable with the path and then simply use, okay, here it is, the OS, the operating system list there function with the path in a loop, and it prints all the files in that directory. You can use filters and so forth. But what I wanted to show you is this is cool. This is like a whole bunch of files. Each one has a year and the baby names in frequency in the popularity order, starting from 1880 every year going all the way to 2010. And with this data, which is a cool little thingy, you can exercise some of the pandas and statistics functions with something that's kind of fun, I suppose. So what I did down here with pandas is I printed it. I printed the one for your birthday, birth year of birth 1989, with just a simple pandas function there, the CXV. And here you have them. You have the first 4, 5, and the last 5. And oh, it took interesting. It took the first line as it doesn't even have an index there. That's an interesting thing to see. But you see the most popular names, the year you were born for females, and then actually this is the least popular names because it's the last, but are males. So the files are arranged females and then males, more popular to least popular. So these are the most popular female names in 1989. All right. Example B. In example B, we print the contents of an XML file, the contents of the tables tags. Like this is one of the HTML tags. When you want to display stuff in a web page in tabular format, you use that tag. And to use this functionality, the functionality here in this example, you need to install into Python per se a couple of uh, plugins. One is called Beautiful Soup for HTML5, and the other one is called lxml. You can use pip to install them, or conda. I use pip because I'm not using conda. Pip, you do it with the command prompt. I can show you how to do that if you need to. Just let me know. In this case, if the table in the HTML file is too wide, pandas will put a slash like that, a backslash, at the end of it, telling you that the continuation in the display is actually horizontal to the same column. You'll see what I mean. Spam here, this file, spam HTML, it's not spam in the sense of bad emails. It's spam as in the food. It has the chemical nutrients in milligrams and nanograms and so forth of that food, that kind of meat stuff. That's in cans, canned meat. So this is it right here. You just use the pd.read_html and pandas takes care of the whole shebang. So you see the nutrients. I don't know what proximites mean, and that's the scientific term. I don't know for the columns there, but this is units. You see, milligrams, grams, kilocalories. This is the amount, I suppose. Then, if you see this slash here, you see the records are 0, 1, 2, 3, 4, and if you see the slash, it means that this chunk here actually goes to the right there. It's still the same row 0, row 1, you see what I'm saying? So these are the not numbers and stuff like that. Anyway, yeah. Example C. Parsing XML. What is XML? XML is very popular out there. It's like HTML, but instead of using the built-in tags like body and footer and paragraph and bold and so forth, you use your own. You create your own tags. Very popular out there. You should become familiar with it. The book came with a number of huge XML files. One of them is City Transit of New York. Studies on the performance of the subway and the buses and so forth. Here, you're going to use that lxml object called objectify .parse, and you put a path, which is the path here in my machine, to the file, the XML file, and then you use this thing here, parse.getRoot. That takes because the XML files are like hierarchical, so you want to get to the top level. Then obviously you create a list here called data, another list here for the fields that you're not interested in, the tags, the XML tags that you're not interested. These are going to be skipped in this loop here. In this for loop, use that thing there, root.indicator for every tag. This is a dictionary, initialized there. For every child in the hierarchy of the tags, get the children. And to implement this skipping, if the tag is in this list, it continues, so it skips that one. It doesn't add it here. Okay? I don't know that pi value there, but suppose you'll find out. It's appending to the data list, and then we make a data frame out of it, out of that list. It is the XML data frame. Then I don't know why you have to do this one, and then you print the XML frame. And that would be this shebang of stuff here. That file looks like that, where all of these tags, it looks a little bit like HTML, but it's custom. It's your own extensible markup language, XML, extensible markup language. So you create tags like that, and it's hierarchical. See, this one is matched to the end here, and then you have data in there. And the tags tell you what the data are. Alright. Now, if you were to display this on a web page or make a book from a book, this is used to edit books. You need an XSD, which is like the how to format, how to print them. So each of those tags in the XML has an associated way of displaying, which is defined in the XSD. Alright. So there we go. An easy one for tonight. I wanted to show you the XML tutorial in this nice website that I hope you've been using for Python. XML stands for Extensible Markup Language. It's made to transport data, and you create your own data. You see, this is a note from here to here, then the fields to, from, heading, body.